There's a photograph taken from the harbor in 1966 that shows the lower Manhattan skyline as it existed before everything changed. The skyline is dense and varied. Dozens of buildings of different heights and ages crowded together on the southern tip of the island. The older stone towers of the early 20th century standing beside the glass and steel boxes of the post-war era. The whole composition irregular and organic. The product of a century of accumulated decisions made by hundreds of different developers with hundreds of different intentions. It is a recognizable skyline, a beautiful one in its way. And in the lower left corner of the photograph, if you know where to look, you can see the beginning, a cleared site, raw earth where buildings once stood, the first visible evidence of what was coming. Within 7 years, 2 towers would rise from that cleared earth to a height that nothing in New York had ever reached. They would become the most recognizable structures in the city's skyline, the defining vertical markers of Lower Manhattan, the symbols of American commercial ambition at its most literal and most monumental. They would stand for 28 years, and their construction, the 7 years between the first excavation in 1966 and the formal dedication in 1973, is one of the most extraordinary engineering stories in the history of American building. The World Trade Center was not conceived as a real estate project. It was conceived as an economic intervention, a deliberate attempt by the Port Authority of New York and New Jersey to reverse the decline of Lower Manhattan as a commercial center. By the late 1950s, the financial district at the southern tip of Manhattan was losing ground to Midtown, where the post-war office building boom had created a newer, more modern, more accessible alternative to the aging downtown stock. The banks and corporations that had historically anchored Lower Manhattan were beginning to consider relocation. The streets of the financial district were narrow, the transit connections were adequate but not exceptional, and the buildings available for lease were old enough that their mechanical systems and floor plates could not accommodate the requirements of modern corporate tenants. Something had to be done to make Lower Manhattan competitive again, and the Port Authority, a bi-state agency with both the mandate and the financial resources to undertake large-scale development, decided to do it. The original concept, developed in the early 1960s, was for a trade center, a complex of buildings dedicated to international commerce, providing office space, meeting facilities, and support services for companies engaged in import and export. The site chosen was on the west side of Lower Manhattan, in a neighborhood called Radio Row, a dense commercial district of small electronic shops, service dealers, and light industrial businesses that had occupied the blocks between Cortlandt Street and the Hudson River for decades. The merchants of Radio Row were not consulted about the decision to demolish their neighborhood. They were informed. The displacement of approximately 300 businesses and their owners and employees was treated as an administrative matter, a necessary precondition of a project too important to be delayed by the preferences of the people whose livelihoods occupied the site. Some businesses relocated. Some closed. The neighborhood that had existed there for generations was gone within a few years of the Port Authority's announcement. Cleared as completely as the orange groves in Anaheim had been cleared, the land assembled into the 16-acre superblock that would become the World Trade Center site. The architect chosen for the project was Minoru Yamasaki, a Seattle-based designer whose previous work included airport terminals and corporate headquarters in a refined, somewhat decorative modernist style that was distinctive enough to have attracted national attention, but not so avant-garde as to frighten the Port Authority's conservative institutional clients. Yamasaki's selection was announced in 1962, and he spent the following years developing a design for a project whose program had not yet been fully determined. The Port Authority initially envisioned a complex of medium-height buildings. Yamasaki initially proposed a cluster of structures arranged around a plaza, with no single dominant tower. The decision to build 2 towers of extraordinary height, the tallest buildings in the world at the time of their completion, emerged from a combination of factors, including the economics of the site, the Port Authority's desire for maximum rentable floor area, and the particular kind of civic ambition that New York had always expressed through its skyline. Yamasaki's final design for the Twin Towers was architecturally unusual in ways that were not immediately obvious from a distance. The exterior of each tower was a structural tube, a load-bearing facade of closely spaced steel columns, each 14 inches wide, separated by windows 22 inches wide, the columns and windows alternating in a vertical rhythm that repeated 59 times around each face of each tower, 236 columns per floor, carrying the wind loads and a significant portion of the gravity loads of a 110-story building without the need for interior structural columns across the full width of the floor plate. The absence of interior columns was the commercial payoff of the structural system. It produced large, open, column-free floor plates that could be configured flexibly for different tenants. A significant advantage over older buildings where structural columns interrupted the floor space at regular intervals. The floor plates of the Twin Towers were each approximately an acre in size. 43,000 square feet of uninterrupted space on every one of 110 floors. The foundation system for the towers presented an engineering challenge that had no direct precedent. Lower Manhattan sits on bedrock, hard schist that lies close to the surface in Midtown, but descends to a depth of approximately 65 feet below street level in the financial district, beneath layers of fill, soil, and the accumulated geological debris of the glacial age. The towers were tall enough and heavy enough that they had to be founded on bedrock. There was no alternative if the structures were to be stable. But reaching bedrock 65 feet below street level in a location adjacent to the Hudson River, in ground saturated with water, required a solution that would prevent the river from flooding the excavation before the foundations could be built. The solution developed by the project's engineers was the slurry wall, a technique borrowed from European engineering practice and never before applied at this scale in the United States. The slurry wall, called the bathtub by the construction workers who built it, was a continuous underground wall of reinforced concrete enclosing the entire 16-acre site, extending from street level down to bedrock, built before the excavation began. The construction sequence was specific and ingenious. A narrow trench was dug around the perimeter of the site using specialized equipment. A clamshell excavator that could dig straight down while keeping the trench walls from collapsing by filling it continuously with a mixture of water and bentonite clay called slurry. The slurry was denser than water, and its density held the trench walls stable while the excavation proceeded. When the trench reached the required depth, a steel reinforcing cage was lowered into it, and concrete was poured from the bottom up, displacing the slurry, which was pumped out and reused elsewhere. The result was a section of concrete wall, reinforced with steel, built in place underground without ever allowing the trench to be open to the surrounding groundwater. Section by section, the process was repeated around the entire perimeter of the site until the wall was complete, a bathtub of concrete 2 feet thick, enclosing 16 acres, reaching from street level to bedrock, holding back the Hudson River. The excavation that followed the completion of the slurry wall was the largest in New York City history. Approximately 2 million cubic yards of earth and rock were removed from inside the bathtub, material that had to be disposed of somewhere. The solution was simultaneously practical and transformational. The excavated material was used to create new land, deposited in the Hudson River along the western edge of the site, extending Manhattan's shoreline westward by approximately 700 feet. The landfill created by the World Trade Center excavation became the foundation of a new neighborhood that would eventually be called Battery Park City, a residential and commercial development that today houses tens of thousands of people on land that did not exist before 1966. The Twin Towers built the ground beneath Battery Park City before a single floor of steel was erected above street level. Steel erection began in 1968, and the pace of construction, once the foundation work was complete, was extraordinary. The structural system of the towers had been designed for speed of assembly as well as structural efficiency. The exterior columns were prefabricated in sections in steel mills in Pennsylvania and other states, trucked to the site, and erected using tower cranes that climbed with the building as it rose. Each prefabricated section was 3 stories tall, incorporating 3 columns and the spandrel beams connecting them. A single piece that could be lifted, positioned, and bolted into place by a crew working at the current top of the structure. The prefabricated floor trusses, the lightweight steel assemblies that supported the concrete floor deck between the exterior columns and the Central Service Corps, were similarly designed for rapid installation, delivered to the site in sequence, and erected in a coordinated rhythm that kept the entire construction operation moving upward at a rate that observers on the ground could measure week by week. The workers who built the Twin Towers were a community as large and varied as the workforce of many small cities. At peak construction, approximately 3,500 workers were on site simultaneously. They included ironworkers from the Mohawk communities of Conowick in Quebec, the same communities that had contributed ironworkers to the construction of New York's bridges and skyscrapers for generations. Men whose reputation for comfort and skill at extreme heights had made them sought after by the structural steel industry since the late 19th century. They included operating engineers running the tower cranes and hoisting equipment, carpenters and concrete workers building the floor systems, electricians and plumbers and mechanical contractors installing the infrastructure of the most complex building systems then attempted in any structure in the world. The towers required their own electrical distribution systems, their own water supply systems, their own air handling systems scaled to condition the air of 110 floors, their own fire suppression systems, their own communications infrastructure. Building them was not one construction project. It was dozens of specialized construction projects happening simultaneously in the same vertical space. The elevator system of the Twin Towers was an engineering innovation as significant as the structural tube, and it addressed a problem that the tower's unprecedented height made acute. A conventional skyscraper elevator system, where every elevator serves every floor, would have consumed so much of the building's floor plate area and elevator shafts that the rentable space remaining would not have justified the construction cost. The solution, developed by the elevator manufacturer Otis in collaboration with the building's engineers, was the sky lobby system. Rather than running all elevators from the ground floor to all upper floors, the system divided the building into 3 vertical zones. Express elevators ran from the ground floor to sky lobbies on the 44th and 78th floors, where passengers transferred to local elevators serving the floors within their zone. The express elevator shafts were stacked vertically, occupying the same shaft footprint in the lower zone, the middle zone, and the upper zone, meaning that the total area devoted to elevator shafts did not scale linearly with the building's height. The sky lobby system allowed the Twin Towers to have 99 elevators in each tower while devoting only a fraction of the floor plate that a conventional system would have required. By 1970, One World Trade Center, the North Tower, had risen above the height of the Empire State Building, then still the tallest structure in New York. The milestone was marked by the press and by the construction team. But the workers at the top of the rising steel were less interested in symbolic milestones than in the practical reality of working at heights that introduced challenges not encountered at the lower floors. Wind was the defining physical fact of construction above the 1,000th foot. At the upper floors of the North Tower, sustained winds of 30 to 40 miles per hour were routine, and gusts could be considerably stronger. The tower cranes operating at those heights were among the most powerful in the world, but even they had operational wind limits that could halt work for hours or days. The ironworkers connecting the prefabricated column sections at the top of the rising structure were working in conditions that required a specific combination of physical skill, spatial awareness, and a particular psychological quality, difficult to name, easy to recognize, that allows a person to function efficiently on a steel beam 4 inches wide, 1,000 feet above the streets of Manhattan, in a wind that makes the beam flex beneath their feet. The topping out of One World Trade Center, the placement of the final structural steel at the building's full height, occurred in December 1970. Two World Trade Center, the South Tower, topped out in July 1971. The structural completion of the towers was followed by years of interior finishing work. The installation of the mechanical, electrical, and plumbing systems, the construction of the interior partitions and ceiling systems, the finishing of the lobby spaces, the installation of the elevator cabs and their operating systems, the fit-out of the tenant spaces that would eventually house the Port Authority's own offices, the offices of dozens of private companies, and the windows on the world. Restaurant at the top of the North Tower. The transition from structural shell to finish building was in some ways as complex as the structural work itself. The coordination of dozens of specialized subcontractors working in a vertical space that required the careful sequencing of interdependent systems to avoid conflicts and delays. The Twin Towers were not universally admired when they opened. The architectural criticism of the early 1970s found the buildings cold, repetitive, inhuman in scale. Two rectangular boxes of identical height and nearly identical appearance. Their facades a relentless grid of narrow columns and narrower windows that gave the eye nothing to rest on and nothing to distinguish one tower from the other. Lewis Mumford, the most influential architectural critic of his generation, wrote about the towers with barely concealed contempt, describing them as expressions of the same corporate gigantism that was making American cities less livable rather than more so. The reaction of New Yorkers who simply lived and worked near them was more mixed. Some found them oppressive, their sheer scale dominating the lower Manhattan skyline in a way that reduced every surrounding building to insignificance. Others found them beautiful in precisely the way that extreme scale and extreme simplicity can be beautiful. The way the light moved across their facades through the day, the way they appeared and disappeared in fog, the way they caught the sunset and turned briefly golden before the sky went dark. On April 4th, 1973, the World Trade Center was formally dedicated in a ceremony attended by dignitaries from the Port Authority, the city and state governments, and the business community. The towers were open, not fully occupied, the rental market for office space having softened significantly since the project was conceived in the optimistic early 1960s. But open, functioning, receiving tenants and visitors, standing at the southwestern corner of the Manhattan skyline as the tallest buildings in the world. The 7 years of construction that had produced them, the slurry wall and the excavation, the prefabricated steel columns and the sky lobbies, the Mohawk ironworkers in the wind, and the concrete workers on the floor systems, and the engineers managing the most complex building project then attempted in any American city, had produced something that would stand for 28 years. That would become as much a part of New York's identity as the Brooklyn Bridge or Central Park that would be. The last thing many people saw on a clear September morning in 2001. They were built by human hands, in human time, with human ingenuity and human labor, and the particular human willingness to attempt things that have never been attempted before simply because they can be done. They could be done. They were done. And for 28 years, they stood.